In this lesson, I want to talk to you a little bit more about cleaning data. We've already gathered all our data and we've started on this process. In particular, what we've done so far is we've extracted the relevant data, namely the email bodies, from all our text files. And we've also converted all the text files into a pandas data frame. In other words, we've taken over 5,000 different files. We've extracted the actual pieces of data that we need from it, and we've converted all of that into a format that we can work with in our Python code. Now it's time for the next steps, namely checking for empty emails, checking for missing values or null values in our data that we've imported into our Python notebook. So without further ado, let me show you how to do that in Jupyter Notebook. I'm going to add another markdown cell right here that reads data cleaning, checking for missing values. Of course, it would help if I could spell a bit better, but there we go. The handy thing is that we've put all our data into a pandas data frame. The first thing I want to do is check if any message bodies are equal to null. By null, I mean that the value is missing. The way I can access a particular column in my data frame, namely the messages column, is by writing data.message. This will access my message column, which looks like so. The alternative syntax that you'll see to accomplish the exact same thing is with the square brackets and then the actual column name between single quotes. So that reads message. Voila. Great. Now, there are 5,800 rows in this column. So if I wanted to check if any of them has a missing value, then I can use the method isNull. What we get in this case is a value true or false based on whether or not any particular value was null or not. Now, this is a very, very handy method, but it doesn't help me check if any of these values is equal to null. I mean, part of the reason is that, yes, I can scroll through here, but Jupyter will actually only display so many rows. It will hide the middle part of my data frame. So what I'm going to do is I'm going to chain some more methods. The first one is this values attribute. And what this will do is instead of giving me the index name and the value here, it will just give me a NumPy array. It will just give me the values without the index. The nice thing about this is that if I wanted to check if any of the 5,800 rows has a missing value, I can use the any method and chain that onto here and get my result. So the good news for us is that the result is false. We have no missing values in our message column. Now, missing values are actually not the same thing as empty emails, right? An empty email would be something like this, an empty string. If I check what this is, I will actually see that it is of type string. This would simply be an empty string, a string of length 0. So what would be an example of a missing value? Say I had a variable called myvar, and we don't want to put any value inside this variable. We simply want it to be empty or contain nothing. How would we accomplish this in Python? Now you might think that given that we've used isNull as a method on our data frame, you could simply write something like myvar is equal to null and create your empty variable. However, even though this null keyword is commonly used in other programming languages like, say, Java, in Python there is another keyword that has the same meaning, and this is the keyword none. And you can see that Jupyter Notebook is instantly picking up the fact that this is a keyword with the syntax highlighting. So in this case, if I was to check the type of my variable, I would see that it is indeed a none type. My underscore var is truly empty. It truly contains nothing. Now, conceptually, the way I like to remember this difference between 0 or an empty string with a null value is with this picture. The internet has truly blessed us with lots of terrible programming jokes, and I'm going to do my best to share them with you. But in all seriousness, this is actually quite a helpful way about thinking about null values, or none values, as they're known in Python. Okay, so even though that we've established that there's no entry in our message column with the value null or none, it doesn't mean that we don't have empty emails that could be in our dataset. Okay, so let me show you how we would write a check for discovering if there are any strings of length 0 in this entire message column in our data frame. I'll add a little comment here that reads check if there are empty emails. Let's say string length 0. The way I would go about doing this is grabbing our data frame, then grabbing the message column, then converting that to a string, and then grabbing the length of these strings. Let's take a look at what this looks like. Here we can see how many characters each email body has in our messages column. Now, if we wanted to check if any of them are equal to 0, in other words, if any of them look like this, we can simply use the double equal sign and then 0 for the logical test. If I press Shift Enter now, we again get an entire column of true or false values. All right, we can't look through 5,800 different messages, so the any method is our best friend again to see if there are any rows where the value is equal to true instead of false. Let's take a look. Aha! So there are some empty emails somewhere in our data frame. What we don't know yet is how many of these rows have a string length of 0. So how would we check that? Well, we could take our logical test here. Remember, this returned 5,800 entries of true or false. Now, the Boolean value of false is equated with the numerical value of 0, and the Boolean value of true equates to the value 1. So if we wanted to know how many rows have a string length of 0, all we would have to do is sum them up. This sums up all the zeros and any ones, any true values in the 5,800 entries. Okay, so we're going deeper down the rabbit hole. We now know that among the 5,800 entries, there are 4 strings of length 0. Now, we have to find out where in our enormous data frame these strings are. We have to find the rows that contain these empty strings. But before we do that, I want to pose a challenge to you. Namely, I'd like you to pause the video and write the Python code that would check for the number of entries with null or none values. Did you solve it? Here's the solution. Now, I know we don't have any null values in this data frame, but that doesn't mean that your future projects won't be having this issue. So with data.message, we can pull up our message column, and then with isNull, we can find out if there are any null values. And by summing up all the true and false values that we get out of this bit of code here, we can find out the number of null values. Now, the answer of 0 shouldn't be surprising, because we've already established that there are no null values in the message column. But I do think that this is quite an important piece of the data cleaning workflow, so it's good to have this down and practice this once or twice. Let me add some more empty cells here. Now I'll add a markdown cell. And what I'll do here is I'll just write locate empty emails. Let's find out the row names of our empty emails. As you can probably guess, this condition is going to be key. This is what we're going to be using to get a pandas series of true or false values for where these rows are empty. Now, if I wanted to pull out the index names for where these empty values are, then I could select, based on this criteria, where these values are true from our data frame, and then access the index attribute from the data frame. So data, square brackets, and then put the logical condition in here, and then have dot index afterwards. And now we'll get the index names, the row names, for where this condition is true. Let's check it out. Okay, so this is interesting, right? CMDS, 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 and then dot ds underscore store. These are the index names. Now, does anything strike you as odd with these index names? Let's see how they compare to all the other file names. So just scrolling through our dataset here, we can see that most of these emails actually have file names that look something like this. The CMDS and .dsstore as a file name does seem to be a little bit odd. Let's see if we can find out what these files are. If I go to my spam_1 folder and I scroll all the way down, then I indeed see one of these files here. This actually does not seem to be an email, right? Taking a look at this file here in my Atom text editor, I can see that it looks like this. This is definitely not part of our dataset. The CMDS file is actually a system file that you'll see both on Windows and Mac when you unzip the original email archive. This is not an email file that we should include in our data frame. You'll also find this CMDS file in the spam_2 folder and in the easy_ham_1 folder. Now, what about this .ds_store file? Now, because the file name is preceded by a full stop, by a dot, this ds_store file is actually a hidden file. This is a macOS specific file that stores the attributes of a particular folder. And this system file was created when I downloaded, unzipped, and then rezipped the course materials. In other words, this is not an email. This is an artifact of me preparing the lesson resources for you. Now, obviously, we don't want any of these 4 files in our data frame. We just want our email data. But why are these files in our data frame in the first place if we don't want them there? What happened? Well, let's take a look at our file reading function. Looking at the email body generator code and this walk function from the OS library, we can see that this function actually picks up all the files in a particular folder. And this includes the system files that don't belong in the email corpus. That's how they got included in the data frame. Now, we know the row names or index names for our undesirables in our data frame, but what we don't know yet is where they are. Now, let me show you how to get the location for this .ds_store entry. What we can do with our data frame is get the index, so index dot get underscore location, get location, LOC, parentheses, and then single quotes, and then dot ds_store in the single quotes will give us the row number where this entry lives. So we can search the entire index, so all the names, for a particular name, which is our argument in this getLocation method here. Let's take a look. So here we have it. 4609 is where this entry is in our data frame. If I say data, square brackets, say 4,608 to 4,611, then I can pull up this section of the data frame and take a look at which rows precede and follow this ds_store entry. And there we can see it just happily living between two non-spam emails. In the next lesson, I'll show you how to remove these system files from our data frame. I'll show you how to drop these entries and clean things up a little bit and much, much more. I'll see you there.